Okay, let's dive in. Today we are getting into some really specific professional-grade engineering. We're looking at a piece of hardware with, well, a very technical name. The Thor Broadcast H-1HDMI-DVBT-IPLL encoder modulator. It's a mouthful, I know. But our mission here isn't just to read a spec sheet. It's to figure out what this thing actually does. Think of it like this. You've got an old building, maybe a hospital, with miles of old-school coaxial wiring. How do you get a new high-def camera feed to show up on those TVs?
And that's the perfect way to frame it. This box, this specific device, is that ultimate bridge. It takes a modern digital source, a Blu-ray player, a camera, digital signage, and it essentially teaches that signal how to travel down those old copper pipes that were never designed for HDMI.
So it's a translator, really.
Exactly.
And at its core, its main job is distribution. You plug in any live HDMI source, and this box creates its very own RF channel like a private TV station over your existing wiring.
Right, and we're talking about perfect HD quality. Up to 1080p 60, no compromise there.
But it's more than just one thing, which I found fascinating. It's listed as multi-dynamic.
Yeah, that's key. It can be an encoder, a modulator, an IPTV server, or, and this is the impressive part, all three at the same time.
Okay, let's break that down. Encoder.
The encoder takes that huge, raw video file and shrinks it down using a standard like H.264.
The modulator.
That puts the compressed signal onto a specific frequency. That's what lets a regular TV tune into the channel.
And the IPTV server. That's for the network side of things.
Precisely. It pushes that same signal out over your standard Ethernet data network, so you get the best of both worlds.
Which explains the cost savings, I imagine. One box doing 3 jobs. Now, looking at the inputs, it's got HDMI, obviously, but also something called ASI. What's that for?
That's a great question. ASI is a pro broadcast standard, asynchronous serial interface. It basically lets you inject an already encoded video stream into the mix, so you can combine multiple sources. It's for building more complex channels.
Got it. So that covers the what. Let's talk about the how fast, the IPLL in the name. That's the ultra-low latency feature, right?
Yeah.
What's the real-world impact of that?
That is the secret sauce. I mean, typical encoding can have a delay of, 1,200 to 1,600 milliseconds? Over a full second, you notice that?
A really noticeable lag, yeah.
This unit cuts that down to between 70 and 250 milliseconds. It's incredibly fast. For live events, sports, anything where timing is critical, that's the difference between seeing it live and seeing it on a delay.
That's a huge leap. And on the encoding side, we're talking MPEG-2 or the more modern H.264. What about audio?
It's just as flexible there. Supports MPEG-1 Layer 2, AAC, and the really important one, Dolby AC3. So you're covered for high-end professional audio.
And you manage all of this through a web browser.
Yep, a simple HTTP web server on its own network port, so you can control it remotely.
Okay, here's a question for you. If the point is to use old coaxials, why does it also need all these modern IPTV streaming outputs like RTP and UDP? Doesn't that just add complexity?
Well, because no building is purely one or the other anymore. You might have old TVs in the lobby running on coax, but the new conference rooms need a clean IPTV stream over the network. This lets you serve both audiences from one source simultaneously. It means you don't have to rip out old wiring to support new tech.
So for anyone listening who might actually manage one of these systems, what does this mean for scalability? You can create a whole head end, right? With dozens of channels.
Absolutely. You just stack the units. They come in 1, 2, or 4 channel models. You can daisy chain them or use what's called an RF combiner to merge all the signals onto one cable. It's completely modular.
So the big takeaway here is really about bridging the gap.
It's the perfect example of that. It shows how you can link a brand new high-res digital signal to the legacy RF transmission standards that are, baked into the walls of so many buildings. It's where the 21st century meets the 20th.
Which leaves me with a final thought for you to chew on. Given that one small box can manage all of this, encoding, modulation, IPTV, how much of our modern video experience in places like airports, stadiums, or hospitals is still completely dependent on these clever systems designed to work with infrastructure from 50 years ago? Makes you wonder how much of the future is really just a brilliant layer built right on top of the past.